Okay, I will start now. I think I'm audible, right? Hello.
Yes, sir.
Okay. So I think some concept was I left. I think I just told in a general way what is equalization tank. Few things I left in the third model. So I will try to do that today, and also we will some advanced topic is there in your wastewater treatment, like biofilm, fixed film biofilms, and moving bioreactors, batch reactors. So those things I'll be covering today. So equalization tank, I think the term only make you to understand what equalization is. It's a chemistry term. What happening there? See, if acid and base, two things are there. If you just keep it for few times, some equalization will take place, right? So that concept they are going to optimize in industries. They just put one equalization basin like it after grid chamber. You're seeing now here screens grid chamber will comes. After that they'll put one equalization basin so that any acid coming here or any alkaline coming here. Sometime what happens at different processes they'll make you to flow at one tank. The waste may be coming from different sources, even inside one industry also. One industry, here one waste is coming, and some part here one waste is coming. They just make it to flow at one single tank. So what happens? All things get neutralized here. Some reduction of pollution level will happens before it reaches to your treatment plants. So that is a thing where we provide equalization tank. So if they ask question on this specifically, then you have to tell how you can provide this. Providing the equalization tank, how are you going to provide? Directly. They are written here. Providing inline of flow means directly how the flowing happen. Like that only you can provide. And one more we have offline flow. Means somewhere it is adjusted here, somewhere like this, and they are providing like this. Okay, so there is two way of providing this equalization tank. So we will try to see that. Okay, see here. Yeah, offline flow you're seeing here. Somewhere they have provided here. I think you're seeing, oh, this is equalization tank. It's not directly in the flow. Offline they have provided. Okay, so two way of providing equalization tank you can write down. The asking exam. Okay, so what is the when they will provide inline equalization tank and offline equalization tank? So those things we will see today. So when they will provide inline, uh, see here, yeah, providing when they provide the flow is in the line, like capacitor basin required if it is large, uh, that time they are going to provide equalization basin in the line only. Means when the as the flow is happening, no, the same direction the tank will be there. That is why they are termed as inline flow. So basic thing is they provide inflow line, and requirement of this basin is it need a larger space. That again operation cost it will increases, right? So it helps to achieve considerable amount of constituent concentration and flow rate dumping. Means some concentration it will be neutralized, right? Helps to achieve that. So three advantage you have. So next you have one more offline flow. We will see that it's here. So when we'll provide offline flow, then it is provided off the flow. Capacitor basin required less. If the capacity is very less, then somewhere we can provide this offline equalization tank. Then only excessive more than average flow stored in the tank. Means when flow is happening, if it is overflowing somewhere in grid chamber here, if it is greater than the capacity of what exactly the grid chamber has, so some overflowing happening, that time we can provide simply one equalization tank here. Okay, so that overflow can be controlled. Okay, so that method is there, I think. Yeah, some noises from Bhumika, I think. Can you mute Bhumika? Hello, I'm audible, right? Yes. So I think, I hope you understood this equalization type. Just think in the line they are providing, or sometimes they will provide off the line just to, or if any overflow is happening in the grid chamber, if you provide, it is very beneficial. And that time they will provide. So go through all these notes. I will cover a few more topics today. I think these things I covered yesterday. Now, this is one advanced topic you have, sequential batch reactor. This is very widely used in industry. We call as sequential batch reaction means you have understood now few things. How the treatment will happen in wastewater treatment plant. Lot of process happening there. Individual units are there, right? Lot of things, but it requires larger area, right? So many hectare of land is required, and in your college also we try to plan to install on wastewater treatment plant, but it's not possible. Why? Your college is not, doesn't have more area. When you want to provide treatment plant just to treat all the wastewater, not to waste it, just to use it for garden purpose, they are planning to install one, or just they're planning to construct one treatment plant, but it's not possible. So what we can do at that condition, congested area, but we have to, we don't want to waste water, we want to reuse the wastewater in gardening purpose or something like that. So that time we have a lot of industrial application, where everything happening like a capsule in simple, one cylinder you're seeing, no, one cylinder, everything happens there. Your screening, grid chamber settling, everything, filtration and biological process we have gone through, no. So everything happens inside this tank, capsule type of tanks. You can put it, you can excavate the, soil strata here. Yes, all the soil strata. No, you can excavate and dig it and just place it and close it. Your waste will be flowing. It will treat and it will come as a pure. So this is completely industrial application. And no wonder in Japan it is in practice, but in India also they are planning. A lot of multinational companies are there, so they will manufacture these type of units. So one time investment, it requires a lot of money, but once it installed, you can conserve a lot of wastewater. You can treat it and you can simply use it for any gardening purpose, like that. So what all the technologies are available? Mainly there is, I think, two you have already gone through. This activated sludge process, that is very bad. 70% of the wastewater treatment plant, if there is area is available. Area is the main thing for us. Any industries you see, any college you see, is this area is available. If you visit, Reva College, their area is larger. They already installed treatment plant. Nothing is wasted there. All wastewater, they are treating it. They will use it for some other purpose. So that is the main thing for us, area. So these all you can install in our college also. They are planning. I don't know how they will do it. I don't know. They will do it or not. I don't know. But they are planning to install this sequential gas reactor. Around 3 to 4, they are going to install. So then, what is this? We will see now. What is this sequential gas reactor? So reactor means is what first? So you know it, right? You have understood physical, chemical, biological characteristics of wastewater, right? You have understood that each one has its characteristic. A lot of tests you have done that in lab you have performed, so you have understood that. So because of all this thing only, your waste is treating, right? Your wastewater is treating. So everything is happening in a one thing, in one vessel, one capsule, like that, or tank. That is, we call it as a reactor. Everything is happening there. They will manufacture like that. So that is reactors. So then you have one more term coming up here, sequential batch reactor. So this is somewhere the research people will use this word more often. Reactors means what? They try to think this whole as some condition they develop, and they do some mathematical analysis on this. They try to know what happening there in the reactor. Even when you see a solid waste landfill, the whole site they will treat as a reactor. Whatever happening reaction, no, landfills, solid waste management. So it's a very widely used word by scientists, reactors. So now we will go to the application. What is the sequential batch reactor? uh, See this, wait. Yeah, sequential batch reactor. So you already familiar with activated sludge process. I already told you that 2 times. So that process only works here. Activated sludge process, it works on that principle, this sequential batch reactor. So what needed here in ASP, we used to supply oxygen, right? Some diffuse type of thing. This is the aeration tank. We used to this is some sedimentation tank one here, and after the treatment one more tank we build up. This is very large capacity, this is very small capacity. Okay, these tanks will be very large capacity, these are very very small capacity. Like a bundle they will do, like a lot of aeration tank you can think, and all come up. And sorry, I think I done wrong. Wait. Yeah, so all storage of this sludge will settle in this big tank. This will be very big tank, sedimentation tank or clarifier. No, it will be very big in size. These are very small in size. But writing, I just written some block diagram here. Okay, when you see a site, this will like 10 times larger. These are very small. This whole tank is very very small compared to what the tank you built. Okay, so everything is happening inside a one capsule, one vessel. It is called sequential batch reactor. So it works in ASP, activated cell process. We need aeration, waste conversation we need, and we need clarifier or sedimentation tank like this. Okay, of effluent occurs in the same reactor, but in sequential steps, like one by one step, it will start occurring. Okay, so see here, what are all the steps? When this vessel, I told, if you cut it, or if you try to see what is there inside, you have a lot of arrangements like this, somewhere like this. So first step, second step, like that, lot of division will be there inside one single tank, single vessel. Okay, so first step, we will see that now. What happens, filling up the reactor. So wastewater influent will be filled. In the second step, the reaction take place at some time t. So they will design that time, and there they will provide aeration also. Okay, continuous aeration they will provide. Okay, so here air they will provide. Next, settling of sludge. After aeration, you know that ASP, the sludge will be settled, right? All the solid particle of waste, it will settle in the bottom. So the settling of sludge happens in clarification. One separate tank will be there inside that vessel. Inside that only it will be there. So there it settled. Next, we have to remove this sludge also, right? So that is removed by clarified effluent. So all this thing happens in one single reactor, we call sequential batch reactor. Okay. So one more we have moving biofilm reactor. So yeah, one more you have. I think I covered this removal of sludge, clarified effluent they'll remove, and sludge also they'll remove. Okay. So all step they have written here. I just in the words what happens there. See this. I'll just read this once. Right. Yeah. So reactor first filled with wastewater up to desired volume and flow is stopped. So they will stop the flow actually once it will fill up to a desired volume. Next, content of wastewater is then aerated. So they start giving oxygen to it and mixed for the design time period. So it will mix up with air, all the wastewater. Next, aeration, then they'll stop it. After that, what happens? Solid starts settling out, right? So sedimentation or clarification of biomass carried out separate to separate sludge. Then the effluent from that they will withdraw from the reactor. Any effluent is there, they will withdraw. And finally, deposited of sludge removed from the bottom of the reactor. In the bottom, sludge will be deposited, they will remove it. So fill and draw type reactor, they are going to tell this means you have to fill it, then wait for it, then start your process. And once the whole process finish up, again you have to draw it up, again you fill it. So that is fill and draw type of reactor. Okay. So you have one more thing, moving bed biofilm reactor. This is also some part they will use it, but it's very costly process. Okay. So what is that? I will try to tell you now. So MBBR system we call moving bed biofilm reactor. It consists of aeration tank similar to activated sludge with plastic carriers that provide a surface where biofilm can grow. So it's a plastic carrier aeration tank similar to aeration tank. So it will provide one biofilm surface where it can grow. So carriers made of density closed density of water. So these plastic carriers they will made with the same density where water is there. So the density is equal there. So the carriers will be mixed in the tank by aeration system that will have good contact between substrate in the influent wastewater and the biomass on or carried. Okay. So it's just a moving bed biofilm reactor. They will build this. Okay. I think yeah. So advantage you have it as a it is considered as biofilm process. It requires less space because more concentrated and efficient system is there, less dependent on final sludge and separation. Some advantage and disadvantage they have listed out. So what is that then? Moving bed biofilm reactor means some some it consists of some aeration tank and also some plastic carriers it has. There above some biofilm will develop. So once this biofilm develop, it will act like a membrane filtration, biomembrane. So all wastewater can be treated out. So that is the concept. So this advantage, disadvantage, you go through it. Okay. So some disadvantage also as like clogging is there. We can't do that, and it doesn't need any recycling of sludge. Very important, right? We have to recirculate part of the sludge. So we are not doing that. Like that, few disadvantages. So when you choosing any of the method, they will try to calculate what is the advantage, disadvantage, how much out of 10 scale, what is the scale you're going to give for each based on the area that it occupy, based on the efficiency of the treatment and the cost. So everything they consider and they will give one value, and based on that they will go for it. It's just a method that available in today's era. How the The choosing and all, you have to do that. It's up to the designer. They have to choose. Okay. So yeah. So this and all, I can't say they will ask in the exam because it's very look like industrial application. But what I done in yesterday, that is very important. This trickling filter and your ASP, accurate result process. Those two questions are very important for exam point of view. Okay. So then you have one more topic called sludge digester. I will try to do that today. Right. So this is very important for exam, actuators of process. Yeah. Sludge digestion tank or sludge digester. This is also one more important concept for exam point of view. Okay. So you might any of the three one question you will face in exam in also in internals also. But this internal I will start from fourth and fifth. So you don't have all this thing, but I got very less classes to take for you people. I started very late, so that's why the syllabus is didn't cover up. So I will try to quickly finish this. So it's very easy thing. Theory subjects, not very very less effort you have to put. But some memory techniques you have to know to remembering all those things. Okay. So what sludge digester tank then? So every process you all familiar know the word sludge is nothing but the solid part of the wastewater which will be settled in sedimentation tank or clarifier. So that much you know. But if you treat this sludge or digest the sludge completely, it will be very beneficial for an industry and also any of the treatment you need to earn money also, because the end product you see is nothing but it is full of nutrients like nitrogen and phosphorus, right? So how you will completely convert that sludge, some liquid also be there, right? In sludge, it's not completely solid like soil, right? So we have to completely digest that also and take only or make up to completely nutritions or where farmers will use, they will buy. So up to that level we have to convert. So it start with sludge digestion tanks and then you have sludge digestion beds also. So two processes are there. So first we will try to see what is this sludge digestion tank. So you're seeing on tank it's completely made up of RCC. Three layer you're seeing. One is active layer and supernatant, and some oil will or scum layer will develop and some gas going on. Okay. I think last 10 minutes left. Can you people rejoin? Take on break and I will start it again. Huh? Hello? Okay, then I think I will try to finish with this only. So next class, I want to do fourth model. So I will try to finish this. So it's a tank made up of concrete. So sludge they will deposit here. So what happens when it comes? It will mix with first already the content or any sludge is there. Okay. So you all know after certain times gases and all will be released in any wastewater. So main gases released here are methane gas and carbon dioxide. So methane, in villages, that is the biofuel or they will use as a cooking purpose. So the methane gas will be released here and also carbon dioxide. So once it is mixed here, some other type of supernatant liquid also released and they will collect it by effluent. Okay. So since it's completely closed, right? So only gas will be generated and it takes around 30 days. Once it is put, it take 30 days to generate gases and gas are collected. Okay. So this is how the anaerobic digestion looks. So this typical, full way of section we have. So yeah, supernatant liquid drawn out here. It's cross section, I think. Then you have outlet heats here. This is some operation purpose. Gas ventilators also there here. And manhole means people, if they want to clean it, there is a manhole they have provided. So gas will be collected here and digested sludge, which was they will try to remove from here. Okay, so this is a function. So what I told is written is the para, let's see, methane gas and carbon dioxide. So those things only they will collect. So you try to read all these things since it is a theory. I will not read everything. So some specification you go through this. Okay. So gas collection, they're telling how much gas can be collected. Gas varies from 0.0142 to 0.028 meter cube per capita. Okay. So yeah. So this is also most expected question you can face in this exam. They might ask on this. I've seen question papers. Any of the three, any one, they will ask. Okay. So then I will try to take you to some internet how it will looks in exactly in your right, yeah. Google, I will take you there. So I covered sludge digestion tank. See how it will looks. I'll try to see you. So yeah. So this is a figure. If you visit any industry, it will looks like this. I think it's taking time. Yeah, it's come. So here only it's big. So see here, this is the sludge digestion tank. If you visit any industry, you will see like this. Okay, so many are there. See, this is also one sludge digestion tank. Okay, so what happens here? Some cross section. See here, inside it, everything happens. Here, the people will collect gases. Biogas will be released. So fuel will flow and enters here. So mixed zone happening here. Sludge zone is there. Some effluent they will take it out, and gases also sometimes it will be taken out, or sometimes they will collect. Actually, they collect biogas and they will use it for generating energy. Okay. So what else you have? You have I covered what trickling filter. I think if you Google, you'll get a lot of figures. So this is trickling filter, how it looks. See here. So these are rotating arms. This is coarse bed. It will be sprinkled. All wastewater is sprinkled here. One layer will develop. So eventually it will be peeled off. It will be removed itself. So that is the thing. Next, what we have, activated sludge process. We have see here. For that, yeah, you're seeing a lot of thing here. This is activated sludge process. It is nothing but aeration tank. They are installing air here through this pipe. Seeing no pipe. So complete bubbles happening. So that is how the waste is treating here. Inside sludge deposit, they will collect through pumps. Okay. So that is the diagram. I mean, pictorial diagram. So what else I covered? Biofilm, batch reactor I covered, right? Batch reactor. Sequential. Yeah. So how it looks. Yeah. See here, this is also sequential batch reactor. Complete aeration tanks you're seeing. It will look like this only. Before putting that, rather than putting a lot of things, one batch reactor we can place. Fill and draw type batch reactors. See, it will look similar to your aeration tank activated sludge process. So moving bit biofilm, MBBR techniques. I think last 2 minutes left. So this is moving the biofilm reactor. See how it looks. Above it, the layer, it will provide some surface layer to grow all the microbes. This is moving with bioreactors. They will install this thing here. See, maybe a reactor 1, reactor 2, then settling, then sludge reduction happening. And sometimes, if you want to treat more, they will add chlorine, disinfect. So this sequence means in the sequence order is happening. Here also see, moving bed bioreactors are installed here, right? Instead of simple providing tank, they will provide these reactors inside it. Small reactors. Okay. So this is how this reactors looks. Okay. So yeah, last 1 minute left. I'll try to end this session. If you have anything to ask, you can ask. Okay.
Small scale industry. What are the characteristics of small scale industry? What are the characteristics we can see?
Anything you want to ask?
The owner himself is a manager. Yes. These units are managed in a personalized fashion. So
I'll take those.
In small scale industries, the owner as a manager. Okay.
Okay, then.
Small scale industry unit has a lesser development period.
Abhilash.
Lesser development period. Then scope of operations.
Abhilash,
Present, sir.
Okay.
Present, sir. Present, sir.
Raghavendra.
Present, sir.
Okay, Rakshita.
Yes, sir.
Sir, Abhilash, sir.
Okay. Abhilash, I have taken.
Okay, sir.
Shivan is there, I think.
Yes, sir.
Oh, okay. So then I will try to end this session. I will meet you in the next class. Okay.
Is it me?
Okay.
Compared to large scale units, small scale units are more changed, susceptible, and highly reactive.